discovery, which is primarily used by large banks, insurance companies, GCCs, GICs, and actually it's a vertical agnostic product. So this is used by 1,000+ clients across the globe. And this capability is a new addition to our stack of products, which primarily is focused on whatever we discover from the processes. How can that be used for by a co-pilot to provide real-time knowledge intervention to with two objectives. One is how can we reduce the time to competency, and how can we increase the time, how can we reduce the time to production while employees for existing employees who are there already operating processes, and for new employees who come into the process, how can we make them competent. Now, we have been investing in AI for some time, and this platform is backed by a small language model, which is trained based on the process, the content that we, or the knowledge that we discover from processes through our knowledge process discovery capability. And that is fed into that small language model, and that's the how it is extended to the employees to make them productive is through the Epiflex Copilot. The objective here is that the AI has made it very convenient now to provide real-time intuitive insights or intelligence based on the contextual understanding of the user and what the user is operating or how the user is operating. And that's what the primary objective of this Copilot. We believe that the market potential is huge because there is a increased wave or accelerated wave of adoption of AI in enterprises, and all the enterprises that we are working with have a lot of their internal POCs, or they are at some point in their journey of their AI adoption. And I believe our capability fits very well because this actually can provide tangible benefits from AI, because this is directly impacting the productivity of the employees and increasing the quality of the work that they are performing, hence the effectiveness of the process as well. The differentiation here I would very clearly call out is that there are co-pilots that are available today from the large tech providers are providing, and a lot of new age companies are also, new age startups as well as established tech firms are also providing or claim to provide co-pilots. But the problem is that enterprise cannot bring their data to a cloud co-pilot or cloud LLM, or for that matter, a open source LLM that is brought into the enterprise. It is also difficult to be trained with the contextual knowledge of the organization's processes and its data and its system. Because we have the discovery capability, it gives us a lead in about capturing that information and then producing that learning data, which can be then used to train the LLMs, and it will then be consumed by the co-pilot.
Team, a prompt for you. You're close to 5 minutes. A prompt. Please keep a watch on time.
Okay. So there are several benefits that it drives for the organization, which largely includes faster decision making by the users when they are performing complex tasks. It reduces their learning curve. As I said, time to competency comes down. The whole effectiveness of the process go high, and we can tailor this further as per the very specific processes and the needs of the processes, such that the co-pilot becomes even more contextual to the specific process that the employee is operating in.
So to cover the overall how the application works, so we have a capture engine where the user action business keys are captured. So we deploy the capture throughout the agents where every user action captures. That we will do it for 3-4 days of the capture, and we will discover the capture in the sense what task they have performed, is there any variation in the task, and then we will identify how many validations they are doing, how many errors are doing. So we will analyze the data. From the data, we will create a test data on top of that, and we'll create a live cue card, which will be helpful at the time of agent performing the task. And then we'll create a SOP on top of that. Apart from that, we will take a document which they have a complaints document in the task level. All those data fed into the trained LLM, our own trained LLM. We will fine tune them for their enterprise level on their process. Once that model is fine tuned, we'll deploy on the server. From there, typically we have EPSS Copilot. It guides the end user in the contextual level. So that is apart from that, we will capture the user action, how they are consuming the guide, as well as how they're performing the task. We will get from there. We will improve the um, end user experience from their feedback, and we'll generate a comprehensive insights. Okay, so I'll just show you how UI, where when the user interacted, it shows the annotations in a field level guidance. This is a field level guidance screens what you're seeing. Apart from that, there's a step level. So how this is a cue card which says whenever they're performing the task, it highlights what they exactly performing on each step actually. This is basically a push notification from the AI assistant actually. Apart from that, they can go and search how exactly they want to do a certain task. Using the generative AI, it creates the, based on the question, it creates the, it generate the task and it gives in an intuitive manner so they can understand and they can learn on top of that.
Yeah, so we have covered this earlier, but primarily just to highlight that no, it provides contextual intelligence because of the LLM. It can integrate very seamlessly with the ecosystem because it sits on top of the every application that the user is using, and keeps changing the context based on where the focus of the user is. And it also can provide analytics based on how the user has been using the interfacing with the Copilot. This is a large use case that we have driven, for Account General in Malaysia, where the user set was 80,000 users who had to go through SAP migration, and their time to competency in this case was high because they were completely implementing a new SAP from old systems. So we actually implemented this by doing capture across 1,300 processes, created the knowledge set, used the Copilot to seamlessly drive the change management as well as ongoing production. It had clearly shown a 70% reduction in the overall training time and a 50% improvement in overall productivity, which is 70% reduction in time to competency and 50% reduction in overall in the productivity. So some of the, we have highlighted this in the documentation also, but some of the key things that we see is that, by it certainly reduces stress levels because the employee is not pressurized to perform because they have a real-time assistance, intelligent assistant that is consumable. We believe that this should lead to better work-life balances because they don't have to spend more time in delivering their productivity. It also has sustainability impacts. We believe because we are promoting digital adoption faster. It reduces dependency on traditional ways of operations as well as old systems. Overall, as I said, we are a 20-plus-year-old company. We have 1,000-plus customers. We have a strong retention rate of our clients who have used our capability. Our architecture has been
Team APS, the time is up. The time is up for the presentation. We'll start with the Q&A. Jurors,
Sure.
we'll start with the Q&A. Any of the jurors would like to go first?
Just to escape.
Dr. Gagan, Professor Preslav. Dr. Gagan, you would like to
Yeah,
go
hi,
first?
this
Please
is
go.
Gagan. So, can you please highlight what exactly is the innovation? What is your statement in terms of the novelty?
So the innovation, I would say here is the use of our process discovery, which can work across very diverse kind of user environments, whether it be VDI environment, whether it be or any kind of technology environment, our Discover can work with it. It can capture the process knowledge up to the tune of 95% accuracy, and that knowledge is, because it is, when it is captured, it is captured with context, that what is this activity, what is this task, how is it associated, what are the correlation between different tasks. Hence the learning data that we produce out of that is highly contextual to train the LLMs.
So how much data you think we need to collect before it gets trained?
So we look at the data set. Obviously has to be sizable, but while we do this, we do this across the whole process group. For example, if there are 100 people in invoicing process, we capture the data across the 100 users. My system has the ability to clearly call out repetitions, correlations, so I can very clearly identify variations within this. Obviously, looking at the variation, we take a limited set of data and then we extrapolate it with synthetic data, such that we can train because obviously the data is not enough. No data is enough to capture all the scenarios, but we upfront look at the variances. Looking at the variances, we try to create adequate synthetic data, and then we train the system, train the LLM.
So approximately it's a matter of few days or a month, or
Usually, it depends on the SLA of the process. So, if an invoice processing, or let's say I will take a better example, which is, let's say, insurance claims process. That's a long journey process, which might take 30 days. So every claim has to be processed in 30 days. With variations, this could go 45 days. So I have to capture this at least for 90 days across all the user set to identify most of the variations. Let's say at least 60 to 70% of variations.
okay, so the length of the process determines how much recording of the data needs to be done
Yes, exactly.
to
At
capture
times,
all the variations.
absolutely. Let's say in a 30-day SLA of a claims process, you may process, let's say, 500 claims, but the 500 claims could follow 1,000 different variations, based on the claim type or the understanding of the users and all that. Now based on the variation, I have to then figure out the size of data that I need to require, because some variations manifest more, the others less. So where there is less, I have to augment that with synthetic data.
And then like your system will recognize which variation the user is in, and according to that will suggest the actions.
So we work with our client. My system actually recognizes the repetitions that have happened as the task flowed, between one step to other, or how did the process flow? To find the variations, I work with the client, to understand from their SME what are these different
No,
steps,
I'm asking about the deployment. I mean, when it's being used at that time, at test time, for a given specific user, it has to understand what exactly this user wants to do, right? Intends to do. What's the intention?
Yes.
So how
So
is that intention captured? I mean, how do you know what I do?
there are different type of
And
what we
please
call
be brief. I just want to complete this
just
quickly. So yeah.
the different kind of techniques that we use. One is in the given context of the screen, what is the first of all, I understand that what is the role of the user, because they have logged into the system. I know what is the role of the user. Second is that what kind of systems are they opened up, in the screen, and then what is the flow of that screen. That's how I understand that what is that the user is doing.
Okay, thank you.
Thank you, Dr. Govt. Professor Prisla, your question, please.
Yes, so I had a couple of questions. So one is, are there any security risks? We are monitoring what the user is doing, which is very nice. You are kind of capturing semantic information, right? Kind of what the tasks are, but you are observing what the user is doing. So are there any issues about that?
So first of all, Professor, we actually implement this all in the client environment. So we don't operate off a cloud. So which means I operate in the confines of the IST security guide, infosec security guidelines of the client. So they approve it, before I can deploy it in their. Second is that, as I said, I am already taking the user's role and I also seek the authorization to all the knowledge repositories, knowledge data items which the user has access to. So if the Copilot is being used and the user is trying to ask a question or trying to get to a knowledge artifact which is not in their access, it is always denied. Second is that since I am using a small language model, not a large language model, I have only trained it with the training set data or the data that I have captured from the organization. So it doesn't have any other fact other than what the organization I captured from the organization. So the impact of they getting any outside information also gets reduced. Hence, the threat degree would be low. I would not say it will absolutely be out, but it will be low.
So, I mean, you mentioned my second question is exactly about the fact that you have large language models. Of course, this has many benefits. It means it gets computationally less expensive, and the other benefits that you mentioned, right? It's only trained on the data, but I see kind of there are also two risks. One is that small language models hallucinate much more because they have to go more often in the process of making things up as opposed to reciting something they have seen verbatim. Large language models have more capacity. Second, kind of adapting, training those models, they kind of need much more examples. So kind of large language models are more capable, kind of need kind of any comments on that? Kind of why do you want to go with small, kind of any mitigations of the hallucinations and of the slower running, kind of harder training for smaller or large language models?
I agree, Professor. Our understanding in this dimension is also evolving, but our experience, why we went for small language models was primarily that I can put it inside my client environment and I don't have to. That was the primary reason. Obviously, there are performance and capacity overheads that I have to go with. Most of the clients, wherever we go, we try to keep the data set as low as possible and very contextual. Secondly, we don't approach the implementation from an enterprise-wide drive perspective. Rather, go small, one process by process. Take one process at a time, and go like that.
Yeah, again, I have some last quick question. You have shown many customer companies an impressive slide. So the question is, are those customers of your company or actually users of the solution that you have presented?
So these are the companies which have used my full capability stack, and which means there are four capabilities in my stack. These companies are using a combination of the stack or all of it. The objective of reflecting that slide was primarily to show that there are these large enterprises where I have been able to go in, put my product. Obviously, as I said, all of them are in different phases of their AI journey. And AI being very recent, this has started. We already had a previous version of our Copilot, which was largely rule-based, but around 3 years back, we started moving it to Gen AI.
So what kind of small language models you're training, open source models?
So
And
we are
what kind of
using,
cost and time you typically take to really fine-tune these models?
yeah, so what we do, Mr. Bhupesh, is that we use both Mistral and Llama as our models.
Okay.
Llama for its very diverse, language that it comes along with, and Mistral's ability to kind of, get trained in a very small data set with small data sets. So we use both, but we use them in an ensemble model, which is like while we are training, we train both, and while we train both and use both of them in an ensemble way, and we have created our own logic on top of it with some reference database wherein we check the output of both.
Okay,
Which one is
got it. So Llama, how many parameters model?
so
Which
Yeah,
model?
it's a smaller one. On top of that, we quantize to the minimum level actually.
Okay. Okay. Thank you. Thank you. Pretty interesting work you guys are doing. Keep it up.
Sure.
Thank you for
Thanks.
your presentation.
Thank you.